rational expressions that we're going to focus on is multiplication and division. So we're going to do these two examples together in this video. And then in class with the sub, you'll be trying these three on your own. And like it says in yellow, go ahead and check the key that is on the unit calendar. And then there will be a third video for us to kind of go through division. But let's go ahead and let's focus on these two examples. Just like what it says in the directions, it would be way easier for yourself. So go ahead and do yourself a favor and simplify right away before you actually combine like terms with the multiplication. And what we mean by that is, if you notice, 5x plus 45 has a 5 in common. So we'll go ahead and factor that out and we're left with x plus 9. Now, x squared doesn't really have anything that you can take out, but if it makes it a little bit easier to read, you can rewrite that as x times x. And then we are multiplying that all by 3x cubed, which we can break up into 3 times x times x times x, all over x squared minus 81, which is the difference of two perfect squares, x plus 9, x minus 9. And because technically multiplication, the rule for multiplication with fractions is that you can multiply straight across in the numerator and straight across in the denominator, you're able to actually cancel terms along the diagonal. So x plus 9 is in the numerator on the left-hand side, and as long as it's in the denominator of either side, you're able to cancel that out. So the two x plus 9s cancel. You also have two x's in the denominator, which means you can cancel two x's in the numerator. And then 5 and 3 are both like terms. X over x minus 9, one has subtraction, one is just a singular x. So that really is all that we have right here. So then we can go ahead and say that our numerator is 5 times 3 times x, right? Everything that we have left over. And our denominator is the quantity x minus 9. Now, when we write our final simplification, we always want to make sure that we're putting it in standard form. 5 times 3 times x is 15x, and x minus 9, because of the subtraction, needs to stay together, and there's really nothing else that can be simplified besides 15x in our numerator and x minus 9 in our denominator, right? So then if we kind of head over to that second example, we notice that we are multiplying a rational expression by some sort of just linear binomial. And remember our fraction rules, if there isn't a denominator, we can say that anything really is over the denominator of 1. So if it really, it's a personal preference. If it bothers you that it's not two fractions, you can always just leave it as anything over 1. So 6x squared can be broken up into 6 times x times x. X squared minus 1 is the difference of two perfect squares, x plus 1 times the quantity x minus 1. And 3x minus 3 can be broken up into 3 times the quantity x minus 1. They both have that GCF of 3. And then we can just leave everything over 1. We notice that there's an x minus 1 in the denominator and an x minus 1 in the numerator. And to be honest with you, that really is the only thing that simplifies out, which means we are left with in our numerator 6 times x times 3, all over x plus 1 times 1, if we really want to leave that 1 still there. So when we simplify and combine like terms, we are left with 18x squared, all over the quantity x plus 1. And this is our focus on multiplication, right? Multiplication with two rational expressions is simply still just following our multiplication rules, right? You would multiply, and I'll kind of show some work over here. You would multiply the numerator, and then separately you would multiply the denominator, and then our goal is to reduce down as much as possible. Now, however, when it comes to rational expressions and polynomials, just like we said earlier, do yourself a favor. Do yourself a favor and simplify whatever you can right away. So really, the idea behind multiplication is factor, factor, factor. Okay, so for the next few minutes in class, please go ahead and try these three examples on your own. The key to this whole entire worksheet is located in the calendar for today. And then when you finish these 3 examples and you check your work, you make sure you feel good about them, please go ahead and click on the next link to this video where we'll talk about division. Thanks.